6.2, number 40, solve the differential equation by separation of variables. Okay, so our solution is going to have a plus c because there is no initial value here. Separation of variables, so we need to move the y stuff over. So I have 1 over square root of y cosine squared square root of y equals x. So integrating dx, I have the integral of 1 over this. So I'm gonna make that secant squared. Yeah, I'd say the right side seems just a little bit easier than the left side. All right, so this requires a u substitution. I'll choose u as the square root of y. So then du dy is 1 over 2 square root of y. And we need to solve for dy here. So dy equals 2 square root of y du. Alright, so just working on the left side here, I have the integral of secant squared u over square root of y times dy, which is 2 square root of y du. Okay, so we do have an integral in terms of u, and we do know, hopefully, that the antiderivative of secant squared is tangent. Carl taught us that. So now I have 2 tangent of whatever u was, square root of y, equals, now this is 1/2 x squared plus c. Alright, so now it's algebra, solve for y. So I'm going to divide by 2. So I have the tangent of the square root of y equals 1/4 x squared plus c over 2, which you could just call c. It's a different c, but it is just a c. So now we're just going to do the inverse tangent of each side to get rid of the tangent. So then the square root of y equals the inverse tangent of 1/4 x squared plus c. And then we can square both sides. The inverse tangent of 1/4 x squared plus c squared.